Hello and welcome to AI for Developers. I'm AI Educator Talking Bot. Today's lesson is titled Why I Rewrote My Trading Engine in Rust. Latency, safety and concurrency. My original trading engine, built in Python, suffered from unacceptable latency. The global interpreter lock. GIL. Severely limited concurrency. Backtesting revealed bottlenecks, especially with increasing data volumes and complexity of trading strategies. This directly impacted profitability due to missed opportunities and increased slippage. I needed deterministic performance. Rust offered a pathway to significant latency reduction. Its zero-cost abstractions and direct memory management eliminate garbage collection pauses. This is critical for high-frequency trading. I observed a 5x 10x improvement in order execution speed after migrating to Rust. This directly translates to capturing more alpha and minimizing adverse selection. Rust's ownership and borrowing system eliminated entire classes of memory-related bugs common in C++ and other systems-level languages. This is not just about preventing crashes. It ensures deterministic behavior. A single memory error can cost millions, as seen in other firms' experiences. E.g., the $2.3 million Lambda incident. Rust's compiler guarantees safety at compile time. The GIL in Python severely restricts true parallelism. Rust's fearless concurrency allows for genuinely parallel execution of trading logic. I leverage Rayon for data parallel processing of market data and Tokyo for asynchronous I/O, enabling highly responsive handling of incoming market feeds and order placement. My Rust engine now serves as the bedrock for sophisticated agentic loops. These agents use real-time market data enriched by a private retrieval augmented generation (RAG) system. This system indexes research reports, news articles, and SEC filings, providing agents with contextual awareness for better decision-making. The speed of Rust is essential to keep these agents operating in real time. The system architecture consists of a Rust-based core engine, a data ingestion pipeline, potentially using Kafka, and a distributed computing framework like Ray or Dask for backtesting and model training. Containerization with Docker and orchestration with Kubernetes are crucial for deployment and scaling. Continuous integration and continuous deployment (CI/CD) are paramount. Key performance indicators (KPIs) include order execution latency, fill rate, Sharpe ratio, and risk of ruin. Profiling tools like Perf and Flamagraph are essential for identifying bottlenecks. Optimization strategies involve code profiling, algorithm optimization, and hardware acceleration, e.g., using GPUs for specific computations. Benchmarking against historical data is crucial for validating performance improvements. I am exploring FPGA acceleration for ultra-low latency order execution and deeper integration of AI models for predictive analytics. This includes using Rust to optimize the interface between AI models and the core trading engine. The future of quantitative trading lies in combining the speed and safety of Rust with the power of AI. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.